This lesson is on section 2.4. It's day 2 of the lesson on properties and leading into writing proofs. So in the last lesson we learned all the different properties that we had. We talked about using definitions as reasons. You can use postulates also. We're going to today then start actually writing out our statements and our reasons in a proof. So we start out with what is a proof. A proof is simply a convincing argument. We use deductive reasoning, which means we're only using facts. That's why we learned the properties and postulates and definitions that we've been learning so far. Those are the things we're going to use. A statement, proofs are made up of statements and reasons. The statement is the actual mathematical part of it, and then the reason would be which property, postulate, definition allows you to do what you did mathematically. Proofs are, you're always given two pieces. You have a given statement. That's where they want you to start. That's your jumping off point, so to speak. And then they give you a proof statement, the part that you're trying to prove. So when you get to the proof statement, that means you're done because you've proven whatever it is that you've been asked to prove. Okay, so proofs can come in different forms. The ones we are going to concentrate on in this chapter and the next are two-column proofs. There are also paragraph proofs, which you would write using full sentences. You still have a mathematical part and a reason, but you put it together in a sentence form instead of writing it in two columns. And then flowchart proofs we will look at in chapter 4. So this is what a proof is going to look like. You'll have a given statement and you'll have a proof statement. And then we call them two-column proofs because they're just that. They have two columns to them. So you number your pieces, okay? So for example, let's say you were given the problem 4x plus 2 equals 14. And I asked you to prove then that x equals 3. Okay? So your first statement would be your given statement. You almost always put your given in statement number 1. When we start to do more complex proofs, you might see a couple that the given statement isn't first, but 99% of the time the given statement is going to be where you start. So we would write 4x plus 2 equals 14. And now our reason, remember we've got definitions to use, we've got properties to use, we've got postulates to use. The other thing that you can use is the statement that it was given. If it was given to you, then that's your reason. And in this case, that's what it is. We would say that it was given to us in the given statement. Okay. Sometimes you can use the word simplify. So if you were just putting your like terms together, if you were just putting like terms together, that might be, you could use simplify as a reason. Okay. So then from there you do the algebra, okay? So in order to get x alone, we would minus 2 from both sides. So after you minus 2 from both sides, what are you left with? Well, you're left with 4x on the left, and then you minus 2 over here, so you're left with 12 here. Now, this is where all of our stuff comes into play. How were we allowed to go from this statement to this statement? What did we do? And your answer would be that you subtracted 2 from each side. So which property says that you can subtract the same thing from both sides? That would be subtraction. So we would say it's the subtraction property. Okay. And then our next step in the algebra problem would be to get rid of the 4. So we would divide both sides by 4. And we would get x equals 3 after we divided both sides by 4. And since that's what we did, we divided both sides by the same number, that we know that that's the division property. Okay. And notice that our proof statement, we just wrote it. It's right here. So once you get to that, once you can write your proof statement, you're done. That's the end of this proof. It's a 3-step proof. We had a given statement. We had to use the subtraction and the division property to get down to our proof statement. And that's it. That's how you do a proof. Okay, so let's try a couple. We're going to do this one, 5x minus 12 equals 32 plus x. Okay, and our reason for number 1, it was given to us. All right, so then there's a couple of things that you can do from here. Obviously, the algebra has a little bit of leeway. You can get your x's together first. You could get your plain numbers together first. It makes no difference. I like to get my x's together first, so I'm going to subtract x from both sides. So I'm going to get 4x minus 12 equals 32. And what did I do? I subtracted the same thing from both sides, so that's the subtraction property. I'm abbreviating due to the lack of room here. Next on my list, I would add 12 to both sides. So I'd get 4x equals 44. And since I added the same thing to both sides, that's the addition property. And then my next step, I would divide by 4 and x equals 11. And look at there, that's what I was trying to prove. So now I'm done, but I have to list my last reason. My last reason was I used the division property to divide both sides by 4. Okay. Let's try this one. Let's see here. What are we given? We're given that angle AOC is 139 degrees. That's what we're given. Okay. Now these two are going to be more geometry proofs. This one was an algebra proof. You do the same thing. It's just in these we're working with pictures and values of angles and that type of thing, but you're going to use the same concept. Okay, so we know that AOC is 139 degrees. What we're trying to get down to is that x equals 43. That's what we're trying to prove. So somewhere along the line, we're going to have to do some algebra. So let's look at the picture. Let's get some hints from the picture. What do we know? Well, we know that the whole thing is 139. We know that AOB is represented by x and BOC is 2x plus 10. So if I add those together, I should get 139. But I can't just say x plus 2x plus 10 equals 139. I have to be able to relate the angles to their values. So the first thing I'm going to do is look at the angles and say, okay, I have the angle addition postulate that says one angle plus another angle equals a bigger angle. So I'm going to say that the angle AOB plus, and I should put the measures in here, the measure of angle BOC equals the measure of angle AOC. I know that's hard to read. What I did was I said AOB plus BOC equals AOC. That's what our angle addition postulate says that we can do. We learned that in, a couple sections ago. And now I can, AOC I know is 139. What property allows me to take out the AOC and put in 139? Do you remember? That would be substitution. Remember, substitution says if two things are equal to each other, you can take one out and set it equal to each other. Or take one out and replace it with the other. AOB is made up of x, and BOC is made up of 2x plus 10. All of a sudden, I now have an algebra problem. Okay? So what am I going to do? I'm going to put my like terms together. So I'm going to get 3x plus 10 equals 139. So that would be simplifying, like I said on the last page. Okay. And I need a little bit more room here. Now it's an algebra problem, so I'm going to minus 10. So I'm going to get 3x equals 129. And that would be subtraction because I subtracted 10 from both sides. And then I'm going to divide by 3. And so x is 43. And that was because of the division property. And that's what I was trying to prove. I was trying to prove that x equals 43. So there, I'm done. That's the end of that proof. And that's how you combine the geometry and the algebra, is that the geometry is the actual figures, but most of them are represented by the algebra. Okay, last one. I've been given that LM bisects KLN. Okay, so LM bisects, this isn't going to look very good, but it'll be done. KLN. Okay, and my reason for that is that it was given to me. And again, somewhere along the line, I'm going to have to switch from geometry to algebra because I got to get down to x equals 20. Well, what does it mean that LM bisects KLN? Well, by the definition of bisect, it means that it cuts it into 2 equal parts. So I know that angle KLM has to be congruent to angle MLN. And my reason would be the definition of bisect. The key to using definitions is if they give you a word in the given, 99% of the time you're going to use the definition of that word right away. So if in your given they give you that something's complementary or supplementary or adjacent or something to that effect, then you're going to use the definition of that word right away. All right, because this chunk equals this chunk, but they have algebra representations, we're going to substitute. So instead of KLM, I'm going to write 2x plus 40. And then on the other side, instead of MLN, I'm going to write 4x. And so that's substitution. I took what the pieces were equal to, and replaced them. Okay, now we're back to algebra. So I'm going to minus 2x from both sides. So I get 40 equals 2x by subtraction. And then I would divide by 2, so 20 would be equal to x. And that would be division. And now if you want to be specific, if you look up in the prove, I actually wanted to prove that x equals 20. Now, 20 equals x is okay with me, but if you wanted to be official and get it exactly right, what allows us to flip the sides of the equal sign? That would be the symmetric property. So if you were going to do this maybe at a college level, or if you were going to try and publish a proof and you needed to be exact all the time, then you would use the symmetric property to flip your pieces at the end. Okay. All right, so that's how we do proofs. I'm going to turn it over to you now. We are going to, we have a couple of days worth of stuff here. So pay attention to what day you are on and make sure that you are doing, this is the day 2 assignment, so make sure that you are doing day 2.